In this section, we are doing hypothesis tests for the mean, and sigma is known. And the first method that we're going to look at is using p-values. So step 1 says, verify that either the population is normally distributed or the sample size is greater than or equal to 30. Step 2, we need to state the claim. Step 3, we have to state the null hypothesis and the alternative hypothesis. Step 4, determine if the test is left-tailed, right-tailed, or two-tailed. Step 5, identify the level of significance, the population mean, the population standard deviation, the sample mean, and the sample size. Step 6, calculate the standardized test statistic, which is z, and that's equal to x bar minus mu over sigma divided by the square root of n. Step 7, we need to graph z. Step 8, we have to calculate the p-value. Now, for left-tail tests, p is equal to the area in the left tail. For right-tail tests, it's the area in the right tail. And for two-tail tests, p is equal to the area in both tails combined. Step 9, we have to make the decision. So we have to compare the p-value with alpha. Now, if p is less than or equal to alpha, we need to reject the null hypothesis. If p is greater than alpha, then we fail to reject the null hypothesis. And lastly, we need to write the correct conclusion. A manufacturer of sprinkler systems designed for fire protection claims that the average activating temperature is at least 135 degrees Fahrenheit. To test this claim, you randomly select a sample of 32 systems and find the mean activation temperature to be 133 degrees Fahrenheit. Assume the population standard deviation is 3.3 degrees Fahrenheit. At alpha equal to 0.10, do you have enough evidence to reject the manufacturer's claim? Use the p-value method and show all work. So first, is either the population normally distributed or the sample size greater than or equal to 30? Well, our sample size is 32, so yes. So the problem says that the manufacturer claims that the temperature is at least 135. So that means that mu is greater than or equal to 135. Now, because the claim uses a greater than or equal to sign, this is the null hypothesis. So the alternative hypothesis is mu is less than 135, which means this is going to be a left-tail test. Alpha is 0.10, mu is 135, sigma is 3.3, x bar is 133, and n is 32. So z is equal to 133 minus 135 over 3.3 divided by the square root of 32. And rounded to 2 decimal places, this is negative 3.43. Next, we have to graph z, so it would look like that. Now the p-value is the area inside that tail. So to calculate that, we can use normal CDF, negative 9,999, all the way up to negative 3.43. And that's equal to 3e negative 4, which means we need to move the decimal place 4 places to the left. So that would be 0.0003. So for the decision, we need to compare the p-value to alpha. So 0.0003 is less than 0.10. So the p-value is less than alpha, which means we have to reject the null hypothesis. Now for the conclusion, our wording has to be very specific. Here is the table from earlier. So our conclusion has to follow this template. So in this question, the claim was the null hypothesis, and we rejected the null hypothesis. So our conclusion has to sound something like, there is enough evidence to reject the claim. So our conclusion is, at the 0.10 level of significance, there is enough evidence to reject the manufacturer's claim that the mean activating temperature is at least 135 degrees Fahrenheit.